A very hearty and warm welcome to the viewers of YouTube channel PYTHAGOREAN. In today's video session, numbered V2Ma2 English version, we shall discuss about Pythagorean triplet pertaining to secondary school level syllabus. In our last video, numbered V1Ma1, we presented a non-traditional proof of the Pythagoras theorem. Naturally, a look-back reference to this earlier video will be helpful here. Now, coming back to today's session, first thing is the definition of a Pythagorean triplet. What is a Pythagorean triplet? Basically, it's a group of three real positive whole numbers such that the sum of the squares on two of them equals the square of the third. Reference is made to the original Pythagoras theorem, which states that in a right angle triangle the square on the hypotenuse is equal to the sum of the squares on the base and the perpendicular. Now conversely, here we can state the three numbers of a Pythagorean triplet, each of which are real, positive and a whole number. If expressed in the same unit of length, will therefore be representing the three sides of a right angle triangle. This is a converse statement of the definition of a Pythagorean triplet. An example, suppose the hypotenuse is represented by h, say in a particular right angle triangle it is 5 cm, the base represented by b measures 4 cm and the perpendicular represented by p measures 3 centimeters. Then we go on to calculate the sum of the squares on the base and the perpendicular. That is 3 square plus 4 square, that is 9 plus 16, which is 25 and is equals to 5 square. Therefore, the square on the hypotenuse is equal to the sum of the squares of the base and the perpendicular. Likewise, any three real positive whole numbers which satisfy this condition that the square on one of them is equal to the sum of the squares on the other two will therefore be a part of a Pythagorean triplet. Each of them is a member of a Pythagorean triplet. Here, see, they have satisfied all the conditions. 3, 4, 5 all are real numbers, 3, 4, 5 all are whole numbers, and 3, 4, 5 all are positive numbers. So, okay. So, each of them is a member of a Pythagorean triplet. The next question that comes naturally to our mind is, can 4, 5 and any other number other than 3 constitute a Pythagorean triplet? We have already established that 3, 4 and 5, they constitute a Pythagorean triplet. But if we take any other number other than 3, or maybe 3 and 5 but other than 4, or maybe 3 and 4 but other than 5, will they constitute a Pythagorean triplet? Say, we illustrate with the help of one example that we take 4 and 5 but not 3, something other than 3. So if they do constitute a Pythagorean triplet, that is, if the answer is yes, the three numbers should form three sides of a right angle triangle. So the new number should be root over of 4 square plus 5 square, that is root over of 41, which is not a whole number. So they cannot form a Pythagorean triplet. So we observe the combination is a unique one. That is, three numbers, if they are established to form a Pythagorean triplet, then that combination of those three numbers is an established and unique combination. If you make any change in any one of them, the condition that they form a Pythagorean triplet will be broken. Next question is, what is the use of learning all these things for examination purpose? Well, in examinations, very often than not, a question is asked. Any one number of a triplet is given to find the other two. Question is there a standard methodology available to find the other two? If one of the three numbers is given, well, the answer is yes. A thumb rule method exists, and to access the methodology, please watch BioLimaTech's next video numbered V3Ma3. Thank you.